Hello, my dear students. Today in this video, we will discuss some special problems of continuity and differentiation. Some of the problems are included in the question bank prescribed by the council, and some other problems are included in the CBSE previous year question papers. So let's get into the video with full power and attention. So this is your first question. Discuss the continuity of the function. This is the given function. Also draw a rough sketch of the graph of the function. The first part is a very simple problem, just to check whether this function is continuous or not. But the second part, this part, I am actually discussing this part in deep. The first part you can solve yourself, very simple. So come to the solution of the question. So you see here the possible point of discontinuity is 1, because at the point 1, you see here at the point 1, when x is less than 1, function is this one, and when x is greater than 1, then function is this one. That means the point 1, it is the point of change or point of break of the function, and therefore the possible point is the point x is equal to 1. But any other point, then when x is less than 1, then fx is equal to x plus 2. This is a polynomial function, you know that one. And when x is greater than 1, in that case fx is equal to x minus 2, and obviously that is also a polynomial. And we have a theorem that polynomial functions are always continuous, everywhere continuous. And therefore, for all values which are less than 1 and all values which are greater than 1, the function is obviously continuous function. So only the doubtful point is x is equal to 1. That is why we have written here that here the possible points of discontinuity of the function is x is equal to 1. At all other points the function is obviously continuous, because at those points the function is a polynomial function. So now to check the continuity at the point 1 only. So for at x is equal to 1, we have written here, we have to find the left hand limit and the right hand limit. So left hand limit, it is x tends to 1 minus fx. 1 minus mean x is slightly less than 1, and less than 1, in that case fx is equal to x plus 2. So we apply here is equal to, make this x tends to 1 minus 2, h tends to 0. Then x is replaced by 1 minus this new variable h, then plus 2 remaining same, then putting h is equal to 0. So it is 1 plus 2 will be equal to 3 is the left hand limit. In the similar manner, right hand limit, this time x tends to 1 plus, function is fx, 1 plus mean greater than 1, therefore it is x minus 2, we apply here, then make it h tends to 0, and x is replaced by 1 plus the new variable h, so written here, and minus 2 is remaining there, h is 0, so it is 1 minus 2 is equal to minus 1. So obviously the left hand limit and the right hand limit, they are unequal numbers, so the function is discontinuous. But to draw the graph of the function, we need whether this function is continuous from the right or continuous from the left. You should know everything about the function to draw the graph. Therefore, in this case also, we are to find the functional value. So functional value at x is equal to 1, f1 will be is equal to, it is in the first line, 1 plus 2 is equal to 3. And you see here, this f1 and this left limit, these two are equal. Therefore, by theory, we know that the function is a continuous function from the left side. And this is unequal, therefore discontinuous from the right side. So therefore, you just write here, left hand limit not equal to right hand limit. So the function is discontinuous at x is equal to 1. So first part of the question is actually finished here. But to draw the graph of the function, I already told you that whenever we want to draw the graph of a function, then we have to know each and everything about the properties of the given function. So that is why we have obtained here f1 also. So you write here again, since left hand limit is equal to f1, this left hand limit is 3 and f1 is also 3, so left hand limit is equal to f1, therefore the function is continuous from the left and discontinuous from the right. So therefore we now can draw the graph of the function. You see, this was the function, and to draw the graph of a function, you see, when x less than 1, function is a polynomial function and with degree 1, therefore will be a straight line, we know that one. And similarly for x greater than 1, fx is equal to x minus 2, it is also a 1 degree polynomial, and therefore it is also a straight line. First see the graph, and after that we will discuss step by step about the graph. So this is your graph. You see, when x is less than 1, this point is 0 and this point is 1. When x is less than 1, whatever be the value you are taking for x, but it is less than 1, that means you can take it as 0 or minus 1 and minus 2, minus 3, minus 4 and so on. And if you take, say, x is equal to 0, less than 1 value, x is equal to 0, then its value will be 2. Is x equal to 0, then fx is equal to 2. So 0, 2 is this point. Similarly, if you take x is equal to, say, minus 1, then x is equal to minus 1, then fx is equal to 1 only, minus 1, in that case the value is 1. Similarly, x is equal to, if you take minus 2, then fx is equal to 0, you see here 0, and so on. You may also take x is equal to, say, half. In that case x is equal to half, then it is half plus 2 is 5 by 2, mean 2.5. so you see x is equal to half, point is approximately here, and so it is 2.5 is approximately here, and slowly you proceed to the point 1, that is you take, say, x is equal to 0.6, 0.7, 0.8, 0.9 and so on, and finally you can take x is equal to 1 also. So if you take x is equal to 1 here, then fx is equal to 3, you see 1, then the value is 3. Then if you just give a value for x which is slightly greater than 1, that is, it is of the point, it is like the point 1 point, say 0, 0, 0, 0, 0, 0, a numerous number of zeros than 1, then the value will be put in the second line, because when x is greater than 1, then fx will be equal to x minus 2. So if you put such value 1 point something, then it will be equal to 1 point something minus 2, and so it is minus 1.9 and so on. So x is equal to some point 1 minus 1 point this, minus 0.9999, like this. Okay, so as you proceed by applying the values of x, say up to 2, then it will be 0. Again proceed. If it is 3, then the value is 1, this is the point 1, and so on. But interestingly, you see the tail of this straight line, it will not touch the point minus 1. This is the point minus 1, it will not touch the point minus 1, because if you give x is equal to 1, then its value is not minus 1, its value is 3. So there is a gap from the right side of the graph, and that is why we already told in the previous screen that the function is continuous from the left. Here it is continuous from the left, but it is discontinuous from the right side has a discontinuity in this graph, and so this is the graph of the function. And we take another question of the similar type, and I think you can solve the problem. You see the question first. So this is your problem. Discuss the continuity of the function fx is equal to x plus 2 when x is less than 1, and fx is equal to minus x plus 2 when x is greater than 1. Interestingly, in this problem you see equal sign is not present here. X is equal to 0, that point is not giving here. So it is slightly different from the previous problem, and you see this problem is actually included in your NCERT book example section. You can see the solution of the problem, and very simple. So take the help from there and you can solve the problem, and I think you can also understood the graph of the function from the solution of the problem. And if you have any confusion with the problem, then ask me over the phone. Okay, so this question is homework for you. I go to the next question. This is one important question. If y plus sin y is equal to cos x, then find dy dx. So we begin with this line. Oh, sorry, question has another part. Find the values of y for which dy dx is valid. Actually, this part is important. First part is very simple because it is an implicit function, and we can differentiate an implicit function. We know the methods how to differentiate an implicit function. Everything we know that. But the second part of the problem say find the values of y for which dy dx is valid. That portion is important part. So come to the solution of the problem. So first we write the given function y plus sin y is equal to cos x. So we written here. Then differentiating with respect to x, we write that line differentiating with respect to x. So first y differentiation is dy dx. This is cos y, then dy dx, and this is minus sin x. See, y differentiation is dy dx, sin y differentiation is cos y, and for y you are to write dy dx, and cos x differentiation is minus sin x. Now taking dy dx common only, so dy dx is common. It is 1 plus cos y will be equal to the same thing minus sin x. Then just division, dy dx equal to minus sin x divided by 1 plus cos x. So this completes the first part of the problem to find dy dx. Now the second part, for you have to find those values of y for which this dy dx differentiation is valid. Now you see dy dx is a quotient function. This is a quotient function. Numerator divided by denominator. So it is a quotient function. And any quotient function is defined only when the denominator of the function is non-zero. So you write that line. Now dy dx is valid if, when it is valid, if 1 plus cos y is not equal to 0. And so that will imply cos y not equal to minus 1. And from your first year trigonometric section, we have the general solution for cos theta is equal to 1, cos theta is equal to minus 1, cos theta is equal to 0. We have those solutions, general solutions. So cos y equal to minus 1, the result was twice n plus 1 into pi. But it is not equal to, therefore we have to write the solution like that. Y not equal to twice n plus 1 whole into pi. You are to give not equal to here. And n, where n, this n is belongs to z. So that means y cannot be equal to say pi. If n is 0, then y is equal to pi. Y not equal to pi. Similarly, y cannot be equal to 3 pi, 4, 5 pi, 7 pi. That is odd multiple of pi. In the similar way, y cannot be equal to, say, if you take n is equal to minus 1, then it is minus pi, minus 3 pi, minus 5 pi. Those values y cannot take. And any other value y can take. So this completes the solution of the problem. Okay, so we come to another question. You see the question, test the continuity of the function at x is equal to 0, where the function is given here, fx is equal to this one. And of the same type question we have already done in the previous class, and the question was, I think it was 1 minus e to the power 1 by x divided by 1 plus e to the power 1 by x. I think that was the problem. And this the solution of that problem is already in your copy. So you see the question, take help from that question and solve this problem. I think you can solve very easily this question. So this problem is also homework for you, and you solve the problem and show me through WhatsApp. Now come to another question. See the question number 5. Find dy dx if this is your function sine of xy plus x by y is equal to x square minus y square. Actually the problem is easy, though the problem is easy. I am going to solve the problem. You see the solution of the problem. First we write the expression given, this one. Actually the problem is asked in CBSE final exam. Here I cannot remember, but it was asked in CBSE final exam. So we have written the function given. Then write differentiating with respect to x, because the function is an implicit function. So we write differentiating with respect to x. Then sine function derivative is cos xy, and then xy derivative. You see here sine function. So cos xy remaining same into xy derivative is product function. Therefore x derivative 1, y derivative y is remaining same. Then plus x remaining same and y derivative is dy dx. This plus is remaining same. Then it is a quotient function. You see x by y. This is a quotient function. So denominator is square. Then denominator into derivative of x mean numerator is 1. Need not to write here. Then minus numerator into numerator is x into derivative of denominator y is dy dx. Go to the right side. X square derivative is twice x minus y derivative is dy dx. Complete this product. As well you multiply by y square here. Multiply by y square and complete the product. So y square multiplied and multiplied with y, so it will be y cube. You see y cube into cos of xy. Then y square cos xy into x. Y square cos xy into x. That is xy square cos xy into this dy dx. Then plus this y square is already gone. So y minus x dy dx is equal to this y square is going here. So twice xy square minus y square into dy dx. I think you understood this line and see this line sincerely. So now come to the next line by taking just dy dx common. You see this line. By dy dx common, you see dy dx is present in this term. Therefore inside term xy square into cos xy we have written here. Dy dx is present in this term, so minus x is here. Then this term come to the left hand side, we'll make it positive. So plus dy dx is taken away, and so it is remaining only y square is equal to this term free from dy dx is already in the right hand side, and this term is again free from dy dx. So to shift this to the right hand side, okay, then just dividing it you will get the answer. So dy dx is equal to twice x into y square, this one divided by this total term, and this completes the solution of the problem. Okay, okay, so next we will go to the new question. This is your question. If y is equal to x plus 10x, then show that, this is your question, cos square x d2y dx2, then minus twice y plus twice x equal to 0. This is your question. Actually the problem is in the first side, you can imagine that the problem is a very simple problem, but actually before finding the solution of the problem, it is actually tough, but after solution it will be very easy. You see the question, solution. First write the given expression, y is equal to x plus 10x. Problem is a second derivative problem, so there may be some replacement from the previous lines. So first find the dy dx. You see dy dx will be, this is 1 and derivative of 10x is sec square x. Very simple, but do not differentiate here directly, because you see the structure of the answer. There is cos is there, y is there, x is there, not like this. If you differentiate here, 1 is 0, see twice sec x into 10x will be your expression. So you see here actually we can write this sec square x as 1 by cos square x. You see 1 by cos square x, and then cos square x is multiplied here, cross product. So cos square x then dy dx is equal to this cos square will come multiply by 1, so it is simply cos square x and it is 1 only. You understood this one? And then you find the second derivative, again differentiating with respect to x. This cos square I have taken here to obtain this term. Actually this is the clue to take the cross product in this problem. So after differentiating with respect to x again here, you will see cos square x is remaining same, dy dx derivative will be d2y dx2. Then cos square differentiation, since it is the term cos, will be negative, therefore directly I have written here minus power function twice cos x, and cos x derivative is actually minus sin x, minus is given here, and into dy dx is already there, is equal to, go to the right hand side, cos square function is negative and 2 cos x into sin x. One derivative is 0, need not to write. Then you see here this dy dx value in the answer part, you see dy dx is not present here, so we are to replace this dy dx value, and dy dx is this one, 1 plus sec square x, we are to put here. You see cos square x d2y dx2 is remaining same, minus 2 sin x cos x remaining same, and dy dx is replaced by 1 plus sec square x is this one, is equal to, this is remaining same. Now see, if you complete this product here, it will be equal to minus 2 sin x cos x, and here also minus 2 sin x cos x, left hand side and right hand side, that two terms will cancelled out. So in the left hand side, this term will present as well, this term and product of this term and this term will present, and other term will get cancelled. You see this one remaining same, and minus 2 cos x sin x into sec square x remaining same, minus 2 cos x sin x and minus 2 cos x sin x will cancel from both sides. Okay, so this is your expression. Now till now we have not got the given answer, you see. So here more calculations are there. You see sec square x is actually 1 by cos square x, one of the cos x will cancel, so it is simply sin x by cos x, mean we can write 10x. You see here the line, it is remaining same, it is 2, final calculation will be 10x equal to right hand side 0, then this is remaining same and 2 is remaining same, 10x. You see here 10x is equal to y minus x, so we replace here 2 into y minus x equal to 0. So after completing this product, you will get the answer, minus twice y plus twice x is equal to 0. So that is the solution of the problem. Okay, so we come to another question. First is with the question, if y is equal to e to the power a cos inverse x, condition on x is this one, x cannot more than 1 and cannot less than minus 1, then show that the question is this one, 1 minus x square d2y dx2 minus x dy dx minus a square y is equal to 0. And of this type problems actually we solved in the earlier classes, you can recall or you can check your copy, we have solved these types of problem in the previous classes. So first I am going to solve this problem, don't worry. So you see the solution, we write the expression for y. So it is y is equal to e to the power a cos inverse x. So first find the differentiation, mean the first derivative dy dx. So we write dy dx will be equal to, since the right hand side function is exponential function, e to the power function, so the differentiation remain same. And then you find the derivative of the power function, this power, and it will be a remaining same, and cos inverse x derivative is minus 1 by root over 1 minus x square, minus is given here. So this is your expression. You check the answer part, this is your statement to be proved. The term not containing root over 1 minus x square, it is containing only 1 minus x square. So confirmly you are to make whole squares both sides of this expression, and before that actually this term can be replaced by y. So before that you replace this term by y, you write that line C, it is taken to the left hand side cross product, dy dx is already there, this negative is here, a is here, and this term is replaced by y only. Okay, now you make whole square to free this term from the radical sign, therefore making whole square, it is remaining same, dy dx whole square is there, positive negative will make positive, and a square y square. Now find the second derivative, so again differentiating with respect to x, and so 1 minus x square, this term derivative is twice dy dx into second time derivative of dy dx is d2y dx2. You see the line first, 1 minus x square remaining same, the whole square term derivative is 2 the term itself into dy dx derivative will be equal to d2y dx2. Then the derivative of the first function, it is minus twice x. We have written here minus twice x, and dy dx whole square is remaining there, is equal to a square is a constant number remaining same into the y square function derivative is twice y. Then for y you have to write dy dx. I think you understood this line. Okay, so you see here is a term 2 dy dx, and here is also a term 2 dy dx, and here is also the term 2 dy dx, and can be cancelled out. Therefore you see 1 minus x square remaining same, 2 dy dx is cancelled, therefore remaining d2 dx2, then minus 2 dy dx is cancelled, only remaining x into dy dx is here. This term 2 dy dx is cancelled, only a square y is in the right hand side, taking to the left it is minus a square y will be equal to 0. So that is the solution for the question. Okay, so we take another question. This is your question. If root over 1 minus x square plus root over 1 minus y square is equal to a into x minus y, then show that, it is very important question, you see, is show that dy dx is equal to root over 1 minus y square divided by 1 minus x square. So in the solution part of the problem, first of all you see the structure of the problem. This is the structure of the problem. This is the given expression. You see the term contains 1 minus x square, that is it is of the form a square minus x square, and it is root over 1 minus y square is also of the form a square minus y square, and a is 1 here actually. So in this case, if a term contains a square minus x square type term is contained in the problem, then we have a substitution for x is equal to a sin theta. And here we have two variables. One is x in the structure of a square minus x square, and for y 1 minus y square it is also in the structure of a square minus x square. So for the two different variables x and y, you take two substitutions. For x, say you take sin theta, and for y you take say sin phi. Take both the functions same, sin. If you can also take cos. In that case x is equal to cos theta, y is equal to cos phi. The variable should be differ, but the main function should be same, because the structure of the problem is same. Therefore in the solution part, first we take the substitution. Let x is equal to sin theta and y is equal to sin phi. We change these two variable only for x and y. Okay, the main function is remaining same. If you take x is equal to cos theta, then you should take y is equal to cos phi, not sin phi. Both these two main functions should be same. You have to change the variable only. For x I am taking here theta, and for y I am taking here phi. Okay, so if you replace these two values here, you see the line, then this line is here, and putting x is equal to sin theta, it is root over 1 minus sin square theta, root over 1 minus sin square phi, root over 1 minus sin square theta, that is equal to cos theta. So we write that line cos theta, then plus root over 1 minus sin square phi will be equal to cos phi. A is remaining same, x is sin theta written here, y is sin phi written here. Okay, now you see it is of the form cos c plus cos d, and this is sin c minus sin d, like that. So we apply that formula. So twice of cos c plus d by 2, this is theta plus phi by 2, into cos c minus d by 2, so theta minus phi by 2. This is the formula for cos c plus cos d. Go to the right hand side, equal is here, a is remaining same, it's sin c minus sin d. So twice of cos c plus d, that is theta plus phi by 2, into then sin c minus d, so sin theta minus phi by 2. This is the expression. Now you see here, actually you see here this term cos theta plus phi, cos theta plus phi, these two terms get cancelled out. As well you see this 2 and this 2 will cancel. So what are the remaining terms? The remaining terms are, you see here, cos of theta minus phi by 2 and sin of theta minus phi by 2, and here is a. So if you take this term as denominator, this term as denominator of cos, then it will make it cot theta minus phi by 2, and on the right side just a will remaining there. Okay, so you see the next line, cot of this makes cot of theta minus phi by 2 is equal to a alone. Is that clear? Okay, then theta minus pi by 2 will be equal to cot inverse A. Simply theta minus pi by 2 equal to cot inverse A, and then take the cross product this 2 here. So theta minus pi is equal to only 2 cot inverse A. Right hand side is a absolute is a constant, not absolute constant. It is a constant. So when we take the differentiation, the right hand side will be 0. And now before differentiation, I see this theta and phi. This was substitution for x and y, and therefore you again replace theta. You see here theta will be is equal to sine inverse x, and phi will be equal to sine inverse y. You replace here. So after putting, you see it is sine inverse x minus sine inverse y is equal to 2 cot inverse A. Now differentiate. So you take differentiating with respect to x. So sine inverse x differentiation is 1 by root over 1 minus x square. Then this minus is there. Sine inverse y derivative is 1 by root over 1 minus y square, and into, for y you are to write dy dx, and the right hand side is a constant number, therefore it is equal to 0, derivative equal to 0. Now simply dy dx will be equal to, this term will go to the numerator and shifting to the right side. So you will have dy dx is equal to root over 1 minus y square divided by 1 minus x square, and this total term can be write under a single radical sign like this, 1 minus y square by 1 minus x square. So this completes the solution of the problem. Okay, so we come to another question. You see this question, see here and compare with the previous problem. Just we already just solved the problem here. You see 1 minus x to the power 6, and it is root over 1 minus y to the power 6, and here a into x cube minus y cube. If you compare this question with the previous one, you will see that this x cube whole square and x cube, here x cube, in the previous question it was x square and here was x only. So in this case, x to the power 6 can be written as x cube whole square, and y to the power 6 can be written as y cube whole square. And so this time you take x cube is equal to sine theta and y cube is equal to sine phi. And the rest of the section will be similar to the previous question. And you see the solution will be like this: dy dx is equal to x square by y square into root over of this one. This part remains similar to the previous question, but here the extra term will be equal to x square by y square. So you should keep in mind that whenever you are finding the derivative of x cube, then it is thrice x square. So 3 will get cancelled. So you can solve this problem by taking the help from the previous question, just this question. Okay, so we come to another question. You see, this is the question. If y into root over this 1 minus x square plus x into root over 1 minus y square is equal to 1, then show that the problem is this one: dy dx equal to minus of root over 1 minus y square by 1 minus x square. Same problem here also. You take x is equal to sine theta, y is equal to sine phi. So it is sine theta cos phi, cos theta sine phi format will be there. Sine theta plus phi, or cos theta plus phi, or sine theta minus phi, or cos theta minus phi. Out of these 4 formulae, one of the formulae will come here, equal to 1. Then you free theta and phi from the left hand side. Right hand side will get cos inverse 1 or sine inverse 1, or either cos inverse 1 or sine inverse 1, anything. And in each case, the right hand side will be constant. Okay, so then you put theta and phi by using your substitution, and then find differentiation. You will get this answer. So try these 2 problems yourself, and if you not able to solve the problems, then ask me. Okay, so we come to a new question. this is one important question. If x to the power p into y to the power q is equal to x plus y whole power p plus q, then prove that dy dx is equal to y by x. And the question has the second part also, d2y dx2 will be equal to 0. Hence show that this one. So first target is to find dy dx is equal to y by x. You take the expression for the question first. So in the solution part, you take x to the power p, y to the power q is equal to the term given x plus y whole to the power p plus q. You see, you do not take differentiation directly here. Though you can differentiate the problem directly, but my recommendation not to take differentiation here. No doubt if you take differentiation directly here, you can obtain the answer, but the problem will be too much lengthy, and that is why we are to use some other optional method. And can you think about the method from here? X to the power p into y to the power q is equal to x plus y whole to the power p plus q. Can you imagine? Can you think about the method? The method is by taking logarithm, because the function is has product power, so you can use logarithm before differentiation. Then it will make the problem, solution of the problem, procedure of the solution of the problem, make it easier. And therefore we take logarithm on both sides of the problem. So log of x to the power p y to the power q is equal to right side is this one. Now applying the property of logarithm, you see this is product, so make it plus, and power will come in front of the logarithm, you know that one. So it will be equal to p log x plus q log y is equal to p plus q log x plus y. You see the line first, this one. Actually this term was log of x to the power p is taken here, and then plus this term was log of y to the power q, so q is taken in front of logarithm, and on the right side it is simple, p plus q will come in front of log, and log of x plus y is remaining there. Now you differentiate. So differentiating with respect to x, you have to write this one. I have forgotten to write here, but you are to write here differentiating with respect to x, because the function is an implicit function. Therefore that line is a compulsory line. It will me. Okay, so differentiating with respect to x, p is remaining same because it is a constant number. Log x derivative is 1 by x. Then q is remaining same. Log y derivative is 1 by y, and for y you are to write dy dx. P plus q is a constant number. Log x plus y derivative is 1 by x plus y into the inner function x plus y derivative is 1. Then y is equal to dy dx. Derivative of y is equal to dy dx. So this is the differentiation of the function. Now just to simplify it, you see the next line. It is p by x q by y dy dx is equal to, this is p plus q, completing the product actually on the right hand side, completing the product. So p plus q by x plus y, then plus p plus q by x plus y into dy dx. Now these two terms have, you see this term and this term contains dy dx. So you are to shift, you have to take both of this term containing dy dx in the left hand side and other term to shift the right hand side. And you see here, taking dy dx common, okay, then here q by y remaining, and here this term shifted to the left, so we'll get negative, and p plus q by x plus y, simple. And equal to the right hand side contains already p plus q by x plus y, and this term free from dy dx will go to the right hand side, so it is minus p by x. I think you could understand here. Now just taking LCM here and here, so dy dx LCM is y into x plus y, y is cancelled here, then q into this term, so qx plus qy, I have written here qx plus qy, then minus this x plus y is cancelled, so y into p plus q, so minus py minus qy. In the similar way on the right hand side also, x into x plus y is cancelled, so p plus q into x, it is px plus qx, then this minus x is cancelled, p into this term, so px minus py. Okay, now you see the common terms in both sides, x plus y, x plus y. You see this x plus y, x plus y, x plus y will get cancelled. As well, you see in the numerator here, qy positive number this qy positive number, this qy is also negative number, positive negative cancel, and on the right hand side you see I think px and px, these two terms are cancelled, positive negative. Now you notice the left hand side, numerator of the left hand side, qx minus py, is not it? And notice the right, not the right hand side of numerator of the right hand side, this is qx minus py, qx minus py, and on the right hand side it is also qx minus py. Therefore that two terms will also get cancelled. So actually your term is dy dx into 1 by y is equal to 1 by x. So you can write directly from here dy dx is equal to, simply y will go to the right hand side, numerator of the right hand side, y divided by x. So simply its solution is y by x. So I think till now you understood the problem. Now the next part of the problem is I have written here, you see d2 by dx2, simply it is a quotient function, therefore denominator is square, x into the numerator derivative dy dx minus y, derivative of denominator is 1 only. So this is the differentiation of y by x. Then you just replace the value of dy dx from this line, dy dx is equal to y by x, here you put y by x here. So y by x, if you put that, x is cancelled, and so it is y minus y will be equal to 0. So you just write x, y by x is equal to y, x cancels, so y minus y equal to 0. So d2y dx2 will be equal to 0. So that completes the solution of the problem. And very very important question, you should always keep in mind these types of question, and you are to solve similar problems of this type from your reference books that you have. And now we go to another question of the chapter. Actually it is not chapter, it is uh, a branch of questions, miscellaneous questions, actually different methods and collected from different places. So the problems are actually important questions, and they are also slightly different from the general questions of the differentiation. Okay, so we come to another problem. You see this question, if x is equal to sec theta minus cos theta, y is equal to sec power n theta minus cos power n theta, then show that. This is your question, and here is a tail of the problem also, hence show that this one. This is your question. Actually the problem has two parts. The first part is to show that this line, and the second part is to show that this line. You see, if the first part is asked in your exam, then I think it will carry 4 marks only. But if both these two parts are joined together, then it will carry 6 marks. In your exam, the first part cannot ask, may not ask. Actually, just if x is equal to this, y is equal to this, then show that directly this line can ask in your exam. And in that case, first part, in that case also, you have to prove the, you have to obtain the first part of the problem also. Okay, so question may ask in 3 ways. The first way, just asking up to this line. The second way, asking this line and this line. And the third way, directly asking this line. So if directly ask this line, then first part it is a compulsory line, you must show that. And after that, you find the last part of the solution. Okay, so come to the solution of the problem. You see here, if you sincerely see, x is equal to the function given here, sec theta minus cos theta, y is equal to sec power n theta minus cos power n theta. What's these two functions? See these two functions, sec, cos, that is one is the reciprocal of other. So the question may ask like this, x is equal to, say it is t minus 1 by t, or 1 by t minus t, reciprocal of one another, and this can be t to the power n minus 1 by t to the power n, or 1 by t to the power n minus t to the power n. So the question, if the question gives like that types of terms, t minus 1 by t or t power n minus 1 by t to the power n, then also the answer will be exactly same. Exactly same. If it is 10 and cot, then also the answer will be same. Sec and cos, sine and cosec, in all cases the function answer will be same. These two answer will be same. You got my point? Okay, so come to the solution part of the problem. It is a parametric function, so x and y should differentiate separately, and after that you have to find dy dx. So first you take the expression for x. X is equal to sec theta minus cos theta. So dx d theta, very simple. Sec theta differentiation, sec into 10, then cos theta differentiation minus, so it make it plus sin theta. Then you see sec theta tan theta plus, to make tan theta common, if you write here, you see here divided by cos theta, then it is tan theta into cos theta to eliminate that cos. So we can write this tan theta into cos theta. You got my point? Actually I have written here divided by cos into cos. So sin by cos will make it 10 into cos is remaining there. Then tan theta is common here. You see tan theta into sec theta plus cos theta. Actually my target is make this term similar to this term, just it is negative, it is positive. Okay, and now you take the second one. This is your second one. So first find dy dx. It is power function, so n into sec power n minus 1 theta into sec theta derivative is sec theta tan theta. Since it is cosine function, so make it positive, n will come in front. Cos function derivative is, n into cos to the power n minus 1, and then cos function derivative is minus sine, make it positive. Okay, so you see this sec and this sec to the power n minus 1, if you multiply this by the index theory, power will be n only. Okay, so we write here n into sec to the power n, combining this and this sec into tan theta remaining same, and n into, it is actually what you see, this is cos to the power n minus 1 theta is actually is equal to cos power n theta divided by cos theta. The power is minus a minus b, therefore you can write x power a by x power b. Similar method, it is cos power n theta by cos theta. So cos power n theta is remaining same, and by cos theta combined with this sin theta, so sin by cos will be 10, taking tan theta common here. So as well n is common and tan theta is common, sec power n theta, then cos power n theta. Similar with this term, just difference is positive and negative. Okay, so now you can find dy dx. So dy dx equal to dy d theta divided by dx d theta. This is the value for dy d theta, and dx d theta is in the previous screen, you can see that one. So we put the two values here. Okay, so this is dy dx. Now to make this one, we have a replacement. If this term is negative, then we can replace by y. If this term is positive, then we can replace here x. So to make that, first of all we square this one. Tan theta is cancelled here, tan theta is cancelled. So you see this line tan theta cancel, after this after calculation it will be this one. Now make it whole square, make it whole square. Why we are making whole square? You see in the answer part, dy dx whole square term is actually present there. Therefore we make whole square. Then you see, consider this a plus b whole square. So a plus b whole square will be equal to a minus b whole square plus 4ab. We have the formula. Similarly here also a plus b whole square. So it is sec minus cos whole square, then plus 4 into sec into cos. Is not it? So we use that one. So see the next screen. This one, n square remaining same. So it is a minus b whole square plus 4ab. Is not it? And here also a minus b whole square plus 4ab. And just I told you that this term can be replaced by y and this term can be replaced by x. So we replace that two values here very sincerely. You see, n square remaining same. This is y square plus sec power n into cos power n. Sec power n mean 1 by cos power n. So cos power n cancel, simply 4 will remain there. And here also sec is 1 by cos, cos and cos will cancel, it is simply 4. Then just take cross product here. So this is the first part of the solution. Okay, so come to the second part, directly second time differentiate. So differentiating with respect to x again, this is the product function, so differentiation this, it will remain same, then differentiation this, it will remain same. Very simple. So x square plus 4 into whole square derivative is 2 dy dx, and dy dx derivative is d2y dx2. Then x square plus 4 derivative is simply twice x, and it is remaining same. Right hand side is n square, y square derivative is twice y dy dx, and 4 is 0, need not to write here. Now you see 2 dy dx here, 2 into dy dx is also here, 2 into dy dx is also here, so that can be cancelled out. So x square plus 1 into d2y dx2, then plus here it will remain x into dy dx only, and right hand side it is n square into y only. Okay, so this completes the second part of the solution. So you should practice this problem so many times, so that in your exam, if one of the part is not given in your exam, you can memorize or you can recall what was the first part or what was the second part. Therefore you should try this problem, practice yourself so many times. Okay, so we come to another fresh question. Now you see this question: if y is equal to this sum, then prove that dy dx is equal to this sum. It is also a very important question and included in your question bank prescribed by the council. And so, to do this problem, you begin with the given expression here, take solution. So the given expression is y is equal to this total term we have taken here. Okay, so do not differentiate directly here because it is more complicated. You see, one is 0, okay, this one, then this one, denominator is a product function, again this one, denominator is again a product function. So if you take direct differentiation here, it will be more and more complicated. So before differentiation, you simplify the function to a single function. By simplifying this total term, you make it a single function. After that, we think about the problem in future. Okay, so first you take LCM from these two. You see the LCM x minus a1. So x minus a1, then plus a1 is there. That rest of the terms are remaining same. This positive negative a1 is cancelled. So it is only x by x minus a1, and this rest of the terms are remaining same. And after that, you see again you take LCM between these two. The LCM will be x minus a1 into x minus a2. This is the LCM. So you take that LCM. Then x minus a1 will get cancelled. So x into this factor. X into this factor. So it is x square minus a2x. Written here, x square minus a2x. Then plus, this total term will cancel out. It is simply a2x. So this time positive negative a2x cancelled. The remaining term is x square by this one and this total term. Okay, so next line is see this one by taking also this line is actually the previous line. I have written in the new screen here. So these two terms are cancelled. It is remaining x square by this one, and then the last term is remaining as it is. Now again take LCM between these two, and then LCM is x minus a1, x minus a2, x minus a3, and here these two factors will cancel out. Only this term is remaining. So x square into this factor, it will be x cube minus a3x square. Written here, x cube minus a3x square, then plus this plus, and this total factors are cancelled. This one, only a3x square is remaining. So this positive negative a3x square is cancelled. So now you have the question is this: y is equal to x cube by x minus a1, x minus a2, x minus a3. This is our question. Now you think how to solve this problem. Again, my recommendation is not to differentiate here also, because the function is a product, quotient, some powers, so many factors are there. Therefore, we cannot, we do not differentiate directly here. So, can you think about the method how to differentiate this function in easy method? Can you think? It is by taking logarithm. You see, I am taking log of y is equal to. So by property of logarithm, I have written here in a single line. So log of the total term is this one. So log of x cube minus log of this minus log of this minus log of this. So log x cube is equal to 3 log x minus log of x minus a1, because they are in the denominator, so all of them will be negative. So log of x minus a1, then log of x minus a2, then log of x minus a3. Now differentiate, it will be easier. So differentiating with respect to x, left hand side is 1 by y dy dx is equal to 3 constant remaining same, log x is 1 by x minus log x minus a1 is 1 by x minus a1, and x minus a1 derivative is 1, need not to write here. Similarly here also, similarly here also. Okay, then this y can be take cross product on the right side. Okay, this y you take this cross product at last. First calculate this right hand side. Right hand side. So actually there are 3 times of 1 by x. 3 times of 1 by x. So one of the 1 by x you calculate with the first one. Second 1 by x you calculate with the second one. And third 1 by x is calculated with the third one. You see the line, you can understand easily. See, 1 by x was x and this first factor. Then plus again the second 1 by x and the second factor. Then plus again the third 1 by x, this one. Okay, so this is 1 by x plus 1 by x plus 1 by x is equal to 3 times of 1 by x minus this one, minus this one, minus this one. All these 3 times. Okay, so now take LCM separately here, then here, then here. You take the LCMs. So the first one, x into x minus a1 is LCM, x is cancelled. So it is only x minus a1, then minus x minus a1 is cancelled, it is x only. Similarly here also, similarly here also. You see negative positive x is cancelled, here negative positive x is cancelled, here negative positive x is cancelled. So it is actually minus a1 by this term, minus a2 by this term, minus a3 by this term. That minus can be eliminated with this one by writing a1 minus x. If you eliminate this minus, it is a1 minus x. Similarly here, a2 by a2 minus x and a3 by a3 minus x. Just eliminating this minus with the denominator. Adjusting this negative sign with the denominator. Okay, you see the next screen. This is the previous line, actually, I have written here again. And then the next line will be 1 by x is common, so 1 by x is taken away. It is actually minus a1 by, but I have written a1 by adjusting that minus with the denominator, a1 minus x. Plus, similarly here also a2 by writing a2 minus x to make it positive. Okay, then plus here also a3 by a3 minus x. Next, this y can be taken the cross product on the right hand side like this, dy dx is equal to y by x into this thing. And this was the solution for the problem given. Okay, so now we see another question, important question. This is your question. If y is equal to root over x plus 1 by root over x, then show that this one is again an important question and asked in CBSE. So first to take the given expression, y is equal to root x plus 1 by root x, okay, then differentiate it. So dy dx will be equal to this root x derivative is 1 by 2 root x. Then it is actually x to the power minus half, x to the power minus half. So minus half into x to the power minus half minus 1 mean x to the power minus 3 by 2. And so x to the power minus 3 by 2 can be written as 1 by x to the power 3 by 2. And x to the power 3 by 2 is simply x root x, because it is x to the power 1, it is x to the power half. I have written in this format so that we can take common root x actually. So that is my target actually. Therefore, we have not written here that x to the power 3 by 2, we have written x root x for our convenience only. So then you take LCM here. 2x root x is the LCM. So 2 root x cancel, it is x. So multiply here x minus is this one. 2x root x is LCM, so it is simply 1 here. Now see the solution. Twice x is multiplied by twice x is multiplied with dy dx. Therefore twice x take here. We take twice x dy dx is equal to, so here it is actually x minus 1 by root x. So x minus 1 by root x can be written as x by root x, that is simply root x minus 1 by root x is this one. Okay, then you can replace the value of 1 by root x, because in the answer you see 1 by root x term is absent. Therefore, you have to replace this 1 by root x from this line. So 1 by root x is equal to y minus root x. We write here. So root x is remaining same, minus is here. This is y minus root x is here. Y minus root x. Then this root x positive plus root x plus root x will be 2 root x. So we write here twice dy dx. Then this is negative y. So it is in the left hand side. So it is positive y is equal to, this is simply 2 root x. And that's the answer for the question. Okay. So now we take another question. This one. If y is equal to this, then prove that dy dx is equal to ny by root over x square plus a square. And this problem is a homework for you. You see the question sincerely. Actually, not a tough question, very simple question. First of all, you take dy dx. It will be n into this total term to the power n minus 1 into the derivative of this term. Simply x derivative 1 and root over derivative 1 by 2 root over x square plus a square into x square plus a square derivative is only twice x. Is not it? So now just simplify the term. And as well, in the differentiation line, you will get x plus root over x square plus a square whole to the power n minus 1. And whole to the power n minus 1, that can be written as x plus root over x square plus a square whole power n divided by x plus root over x square plus a square. You can write like that. And x plus root over x square plus x square, that can be replaced by y. You put that value, and the rest of the part is simplify it. Some terms will get cancelled, and you will get the result very easily. This one. So this question is for homework, and you solve and try to solve actually. If you don't able to solve the problem, then ask me. I'll solve it. Okay. So we take another question. You see this question. If y is equal to this one, then prove that dy dx is equal to this. Here, actually, this one is a determinant. This under vertical lines, if you write the array in this process in columns and rows in square format, so they are called determinant. And to solve this problem, actually, we have to know only the expansion process of a determinant. And expansion process of determinant, that means how to expand a determinant, you already know this from the vector part. In your physics first year, in your physics, you already obtained the cross product of two vectors, and in the process of finding the cross product of two vectors, you obtain by the use of determinant. And that was like I cap, j cap, k cap. This is the first line. Then the second line are the components of the first vector given, and then the third line are the components of the second vector given. Then by expanding the determinant through the first row, you can find, or you already found, the cross product of two vectors. So in the similar way, in this question also, we are to know only the expansion process of a determinant, need not to know any other properties of determinant to solve this problem specially. Okay, so first we take the solution of the problem is this expression. So this is your expression, y is equal to the given expression. So we expand through the first row. So y is equal to fx into, then you are to leave the row and the column in which fx containing. So fx containing in this row and in this column. So you are to leave these two. So remaining terms are only these four. So it is just take cross product mc minus bn. We have written here mc minus bn. And whenever we multiply by this gx, we have to give a minus. We will discuss in determinant chapter why it is minus. We will discuss there. Here you just know we have to give a minus sign whenever we multiply by the number in middle. So minus gx into, again you leave the column and row. So now this time L and AC are remaining, cross product LC minus AN, we write here LC minus AN. Then go again plus, this time HX is HX, leave the column and row where HX is situated. So now these four terms are remaining, take cross product LB minus AN, LB minus AN. Now differentiate, and keep in mind that A, B, C, L, M, N, these are constant numbers. So this is a constant, this bracketed term is a constant, this bracketed term is a constant. So differentiation will act on fx, gx, and hx only. So dy dx is equal to, this is fx differentiation f dash x, it will remain same. Gx differentiation g dash x, this is remaining same. Hx differentiation h dash x, this is remaining same. Is that clear? Then again you revert the expression. This expression write in revert form of determinant. So can we write like this? Dy dx is equal to f dash x, z dash x, h dash x, lmn abc. You see, if you expand this determinant, you will get this line. Is not it? F dash x into this column row cancel, mc minus bm, mc minus bm. Then minus z dash x, this is z dash x. Then column row eliminated, then LC minus AM is this one. Then H dash x into this one, and this one will go LB minus AM is this one. So ultimately comparing this line and this line, if this line is the conclusion of this line, therefore this line will be the conclusion of this. Okay, so this completes the solution of the problem. Okay, so we go to the next question. You see, this question is a very important question. If y is equal to x sin inverse x by root over 1 minus x square plus log of this one plus sin inverse this one. And to prove that, this is your expression. Dy dx equal to sin inverse x divided by 1 minus x square whole power 3 by 2 plus 2 by root over 1 minus x square. So this is your question. Actually, in your exam, if you take these two terms only, this one and this one, the result is this one. And for the last part, this part, differentiation is this. Okay, so in your exam, the last part may not give, then the answer will be the first part, first one also. This is only. And in some cases, the last function can also be removed by another function. It is given sin inverse this one. It may be say some sin x only. It may be some cos x only. It may be say log of x only. Anything may be here. And in that case, the result will differ by this term only. Okay. So the conclusion, the differentiation of this function, the conclusion of these two functions combined, the result is this. And this third part comes from here. So if this function is sensed, in the entire result, this term will be sensed. And the first term will remain same for the first two terms given in the question. Okay, so begin with the solution. This is your expression given. Okay, so before differentiation, some simplification is here. So this is root over 1 minus x square is whole to the power half actually. And this term is what? This is by taking, say, x is equal to sin theta. So if you take x is equal to sin theta, then it is 2 sin theta into this term is cos theta. So 2 sin theta into cos theta equal to sin 2 theta. Sin 2 theta. So sin inverse sin will go, only 2 theta will remain there. And 2 theta is equal to sin inverse. So I write the line first, you can understand very easily. Y is equal to this term is remaining same. This whole power half will come in front of the function log of 1 minus x square, and this is 2 sin inverse x. And why it is 2 sin inverse x? I already told you that if you take x is equal to sin theta, then it is 2 sin theta into cos theta. That means sin 2 theta. Sin and sin inverse will remain only 2 theta, and replacing theta by sin inverse x. Okay, so this line is from here. Now come differentiation. So dy dx is equal to, this is a quotient function. So denominator is root over 1 minus x square into the numerator. This is numerator. It is again in product form, x into sin inverse x. So the differentiation of x into sin inverse x, x derivative 1. So it is remaining only sin inverse x. Then compulsory plus x is remaining same, and sin inverse x derivative is 1 by root over 1 minus x square. So first we obtained denominator into derivative of the numerator is this part. Then we give a compulsory negative sign here minus. Then the numerator is x sin inverse x is here into derivative of this denominator. Root over 1 minus x square derivative is 1 by 2 root over 1 minus x square, and 1 minus x square derivative is minus twice x by the chain rule. Okay, so then come to this term plus half is there, log of 1 minus x square is 1 by 1 minus x square, then 1 minus x square derivative is minus twice x only. Then plus this one plus 2 remaining cell, and sine inverse x derivative is simply 1 by root over 1 minus x square. Is that clear? See very sincerely this line. Okay, so we go to the next screen. This line was already in the previous screen. You see, this line was already in the previous screen. Now we are writing this line. dy dx is equal to this root over 1 minus x square into sine inverse x. Then this plus x is there. This term and this term will get cancelled. Only x is there. Then this negative and this negative makes it positive. You see here, makes it positive. Then this x and this x makes it x square into sine inverse x to cancel, divided by 1 minus x square. And whole terms, this square and root over will eliminate each other. It is simply 1 minus x square. Then here it is minus, so minus is taken here. 2 and 2 is cancelled, so it is simply x by 1 minus x square. Plus it can be written as 2 by 1 minus x square. Is that clear? Then we take LCM in the numerator here. Okay, so after taking LCM, you see this root over 1 minus x square into root over 1 minus x square is simply 1 minus x square into sine inverse x is there, plus is there. This will multiply by x, so x into root over x square minus, root over 1 minus x square. Then this is plus x square sine inverse x is remaining same, and this root over x square 1 minus x square will come to the denominator, and this term was already present in the previous line. Okay, so this root over 1 minus x square comes as denominator, and this term is product here, it is product here, and this term remaining same, minus it is as it is, it is as it is. Okay, then we complete this product. You see, sine inverse x, it is x square sine inverse x negative, and here x square sine inverse x is positive, so that is cancelled. So it is x root over 1 minus x square alone. Denominator is remaining same, minus it is same, this is same. Okay, then you come to next line by taking LCM between these two. So LCM is 1 minus x square into root over 1 minus x square. This total term is cancelled, so it is as it is, sine inverse x plus x root over 1 minus x square. Then this minus is here, this term is cancelled here, only root over 1 minus x square will be multiplied with x, so x into root over 1 minus x square. This plus is here, the term is remaining same. Okay, is equal to, you see here, x root over 1 minus x square, x root over 1 minus x square, positive negative cancel, so it is sine inverse x divided by, it is actually whole to the power 1, and this is actually whole to the power half, so 1 plus half is equal to 3 by 2, and plus this term is remaining same, and this completes the solution of the problem. Okay, so we take another question. This is your question. Find dy dx if y is equal to this one. Is important question. And this types of question, another question of this type, similar type, it is given in your NCERT book, in the miscellaneous part, I think. So you can also see the problem and take the question in your copy. Okay, so that question is for you. I am solving this question, and method is similar. This question and the question given in the miscellaneous part of the book is similar type question. So you solve that problem and write in your copy. And here I am solving this problem now. Okay, so take the expression given, y is equal to sine inverse this total term. And you see, it can be modified like this. It is actually 2 to the power x plus 1. This is actually 2 to the power x into 2. 2 to the power x into 2. So this 2 to the power x and 3 to the power x, it is equal to 6 to the power x. So we write like this, y is equal to sine inverse. So it is 2 to the power x into 2. 2 is here, 2 to the power x into 3 to the power x is equal to 6 to the power x. And denominator 1 plus 36 to the power x can be written as 1 plus, this is 6 square, so 6 to the power twice x. Now if we take 6 to the power x is equal to 10 theta to make it a formula actually. Okay, so you see here y is equal to sine inverse 2, this is taken as 10 theta, this one 10 theta, convenient substitution, so 2 10 theta divided by 1 plus, it is 6 to the power x is 10 theta whole square, so 10 square theta. Now you think about this expression, 2 10 theta divided by 1 plus 10 square theta, is it not is equal to sine 2 theta? Yes, so we put that there. Y is equal to sine inverse of sine 2 theta. Okay, then sine inverse and sine will eliminate each other. It is in the principal branch because it is not given any condition on x, therefore it is in the principal branch. So simply you eliminate this sine inverse and sine. It is only 2 theta, so that is equal to 2 into theta is what? You see, theta is equal to, from here, 10 inverse 6 to the power x. So we have written 10 inverse 6 to the power x. Now we can find the differentiation of the problem. So dy dx will be equal to 2 remaining same. It is 10 inverse x format. 10 inverse x format. So differentiation is 1 by 1 plus x square. So 1 by 1 plus x is 6 to the power x square into this part differentiation. 6 to the power x differentiation is 6 to the power x itself into log of 6. Is not it? Log of 6. And so that is equal to, simple, 2 is here, 6 to the power x is here, log 6 is here, 1 plus this can be written as 36 to the power x. So this completes the solution of the problem. And I think you can you understood the problem. Okay, so we go to next of the question. This is your question. Show that ddx of modulus fx is equal to fx into f dash x divided by mod fx. Actually, it is not a question. It is a theorem type question. Actually, in the chapter continuity and differentiability, you recall the chapter. In continuity and differentiability, we discussed that the modulus of a function is continuous but not differentiable. Is not it? Not differentiable at some corresponding point. So here in the question, you see here fx is not given here. It may be any function, maybe sin x, cos x, tan x, any other function, x square plus 1, some polynomial functions, some trigonometric functions, some logarithmic functions, any function can be in place of x, fx. Okay, so no condition is given, but if x function is given, in that case, what is the domain of the function you can determine. But here we cannot find determine, therefore we have not written any condition here, whether it is differentiable at which points, not differentiable at which points. These questions are not coming here. Okay, so how to differentiate a modulus function? Actually, modulus of something is not differentiable at some particular points. But here in this question, we cannot say about the points because function is undefined, given only fx. Therefore, it is a theorem type problem how to differentiate a modulus function, and at which point it is not differentiable, it can be obtained when the function is given. Okay, so come to the solution. You take the function ddx of modulus fx. Modulus fx means actually modulus making the function positive. That means no part of the graph of fx will come below the x-axis. Okay, so positive term can be replaced by like this. It is a positive square root of whole square. Whole square make the function positive. This whole square make the function will make the function positive, and root over will make the function original function. Therefore, mod of fx mean the positive portion of the function is nothing but root over of fx whole square. Okay, then you differentiate it. Now you can differentiate. Modulus is removed here. Therefore, ddx of root over function is 1 by 2 root over function. So we write 1 by 2 root over the function itself into the inner function derivative is twice of fx into fx derivative is f dash x. Is that clear? So 2 and 2 will cancel, is equal to fx into f dash x divided by mod of fx. This term can again be replaced by mod fx because this is actually mod fx. Okay, so modulus of some function, say modulus of cos x is the question. Find ddx of mod cos x. The answer will be cos x into derivative of cos x means minus sin x divided by mod cos x. Is that clear? And in that case, at which point it is not differentiable we can find, because in that case the denominator should not be equal to 0. So cos x not equal to 0 will give the all points where the function is not differentiable. Is that clear? And in case say it is mod x, only mod x, then it is x into 1 divided by mod x. So finally the answer is x by mod x. So the function x by mod x is defined only when x is not 0. So at the point 0 the function is not differentiable. Is that clear now? Okay. So we come to the next part of the chapter. You see this question. If fx is equal to this, then prove that f dash x is equal to this one. Okay, so we take this expression fx is equal to this one, and let us solve this problem by using logarithm. It will be easy than the other methods. So taking log of fx will be equal to this power will come in front of the function, and this is log of a plus x, the division, so it is minus log of b plus x. Now differentiate it, very simple. So differentiating with respect to x, so left hand side derivative will be 1 by fx. 1 by fx derivative is f dash x equals to this a plus b, this is a product function actually, a plus b plus twice x whole into this term. So differentiation of a plus b plus twice x is only 2, because a0 b0 twice x derivative is 2 only. Then whole into the term remaining same here, plus this term a plus b plus twice x will remain same into this part. It is derivative of log of a plus x is equal to 1 by a plus x, then minus this minus log of b plus x derivative is 1 by b plus x. Now this fx will go to the right hand side by cross product, and simple calculation is here. We can combine these two logarithms again. So you see the line f dash x is equal to this fx whole into twice of combining these two logarithms is a plus x by b plus x, then plus a plus b plus x twice x is there, into by taking LCM here a plus x into b plus x. So it is b plus x minus a minus x. Positive negative x is cancelled. So the next line will be f dash x. We are putting here the value of fx. The value of fx is this a plus x by b plus x whole to the power a plus b plus twice x. So we give here. Okay, so 2 log of a plus x by b plus x remaining same. Then this plus is here. So b a plus b plus twice x can be written as b plus a plus twice x, and into this positive negative x is cancelled. B minus a is there. Okay, now it is putting just x is equal to 0 here. The question is asking for f dash 0. So you take f dash 0 is equal to a plus 0 by b plus 0. So it is simply a by b. To the power a plus b plus 0 mean a plus b. Whole into twice of log is there. A plus 0 by b plus 0 mean a by b, plus it is a plus b plus a into b minus a will be equal to b square minus a square divided by a into b, because x is equal to 0. So this completes the solution of the problem. Now we can finish the chapter differentiation here. Okay, so each and every type of questions are discussed in the previous classes, and this class completes the differentiation process. So you see these problems, practice these problems frequently, so that you do not forget the problems. So regular practice must be there. So we can finish the chapter here. So till then, thank you very much.